Hello children, welcome to channel Sube. Children, today I am going to discuss question number 9 from the MCQ part of 2021 Physics New Syllabus paper. The figure shows a composite string made of same material. The cross-sectional area of string B is twice that of string A. The other end of the string B is attached to a fixed wall. So here it is fixed. If both the strings are under same tension, T, under same tension, which of the following graphs best represents the variation of speed V of transverse waves generated in strings with distance x? So the wave speed must be equal at some value here, so that means up to this place some value constant. So when the wave enters this new medium, because the cross sectional area is different, so what happens to the speed? It may be lower, it may be higher, like this. The velocity, we have to find out the speed of B. Actually we have to find out speed of the speed of sound in medium B. Speed of sound or mechanical wave, this one is a mechanical wave, so that the speed of this wave we have to find in medium B. So here these graphs look something equal, but this one, the level is, in this graph the level may be the half V divided by 2 if this one is V. So we have to check that also. This one is something larger than half value is this one, so larger than half. Very little amount is decreased. So here half of the velocity is decreased, here little amount of velocity is decreased, here here totally twice, something close to twice. So like that, increased, here not change. So let us check this whether which graph is correct. So children, let us use some symbols. Let us suppose that the speed or the velocity of this string A is VA, the velocity of this string B is VB, then cross sectional area of this string B as AB, area of B. So here area of A, big A and small a, like this, and the tension equals, because they have mentioned that also, and also we know tension equals therefore capital T. So density let us take as rho, because the same material, so we don't have to write rho 1, rho 2. Since these strings are made of same material, the density here is rho, then density here also is rho. So let us use these symbols. Then first of all let us check what they exactly want us to find out. Same tension, which of the following graphs best represent? We have to select the suitable graph. In this graph, what is the variation they have taken to y-axis, that is the velocity or speed, to x-axis the distance from this place, like this. They measure the distance, and the velocity, actually we have to find out the velocity. So velocity of A, this one is velocity of A, this one is velocity in medium B. This one is the velocity in medium A, this one is the velocity in medium B. Whether it is decreased when the wave transfer to the B medium, whether it is decreased or increased, that is what we have to find out. However, we have to find out is velocity B. So we have to get the picture clear like this. First of all, we have to find out this one, what happens to velocity B, or the relationship between VA and Vb. That is what we have to find out. So now the question is clear. So children, now what we have to find out is the velocity in medium B. So this one is a string. So we have to now recall the equation, the formula which gives the velocity in a string. So this is the equation. First of all, you have to recall that and get into your mind what is the equation that gives us the velocity of a along a string. So these symbols then you have to remember, you have to recall what is this T, what is this M. So T is tension. So symbols are like this. Capital T is the tension, then simple M is the mass of a unit length, not the total mass, remember, not the total mass. Then let's try to find out a relationship for these variables and try to get an estimate what is V, what V is going to be. So the length of mass of a unit length, so imagine that this one is the unit length, say from this string, this length is a piece. If we take a piece from the string, if the length of this one is 1 meter, assume that small piece whose length is 1 meter. Imagine that this length, the total length may be 5 meter or something like that. So now we have taken a piece whose length is only 1 meter. So the cross sectional area is A, B or A, whatever, say the cross sectional area is A. So the density is rho. So what we are trying to do, we are trying to figure out a value for this simple M. So the density is rho. Then how to find out mass of this one, because this one is the unit length. Now unit length means if the length is 1 meter, that is called unit length. So what we need is the mass of this one, mass of this piece. So now we have to find out the mass of this piece. So the relationship rho equals mass divided by volume. So I write the total word because I can't write V, because there is V already we have taken for velocity. So what we need is mass. Mass equals rho times volume. So what is the volume? This one is a cylinder. So the length L times cross sectional area, that is the volume. So cross sectional area times length. But we know here the length is 1 meter. Therefore this L is going to be 1. Therefore we don't have to write it. It is just 1. So rho times A. So this one is the mass. So now we know mass of unit length is this value, rho times A. So here now we have to substitute that term to this equation. So now let us write V equals capital T is common for both, divided by M is this one, mass of a unit length is rho times A, area. So let us first write the equation for this string A. For string A, so this V is going to be VA tension is common, then rho is common, then area of the string A. So I write a small a here. These symbols we can take here. So this one is the equation 1. Now the same way, let us write the equation for this string B. Then VB equals root tension common, rho common, area of B. Now what we are going to find out is this velocity of B. So now we have taken two equations, so we want to find out this one. Therefore let us divide the equation 2 by the equation 1. Then we get VB divided by VA equals, since this one is B, since the root is common, T divided by rho A B, small b, and divide by this thing. So you have to multiply it after inverting, rho A of A comes up the line, then T below the line, like this. So now we can simplify, rho cancel, T cancel, then what we get, VB divided by VA equals root capital A small a divided by capital A small b. So now we know, in the question they have given the cross-sectional area of string B is twice that of string A. So that means string area of string B is twice area of string A. So that we can write here now, A small b is equal to 2 times A small a. B is bigger. So now let us substitute to that above equation. VB divided by VA equals root capital A small a divided by, instead of area of B, we can write 2 times area of A. 2 times area of A. Now again let us cancel this A, and what we get, VB divided by VA equals 1 divided by root 2. Then what we want is VB, then we isolate it, VB equals 1 over root 2 times VA. So to get the final relationship, you have to simplify this one. What is the value of 1 over root 2? If it is just root 2, the value is 1.42. If it is 1 over root 2, the value is 0.7071. You have to keep these things in your mind. Just let us say, let us take only 0.7. So now let us write it here. Now we get the relationship VB equals 0.7 times VA. We substitute this to this one, then we get something like this. So children, final relationship is this one. VB should be 0.7 times VA. So the graphs, let us go to the graphs now. So here, if we say this one, this value is 1, then this value represents the velocity in B. So that should be at 0.7. So this length you have to divide into 2, then this one is the middle. Middle means 0.5, not 0.7, because if this one is 1, this one is 0.5. So in this graph, the velocity in stream B has decreased to 0.5 times VA. So that is wrong. Therefore, what we have to find out 0.7 time VA. So let us decide this one is wrong, therefore, because this value is what? 0.5 V, because this one is V here, you see, this value is E. So this one is for A, this one is for B. So here, if this one is V, then the center is somewhere here. So it is reasonable, we can, if we decide this one is 0.7, because just a little bit above 0.5. So this one is 0.5, this one is the middle, so this one may be 0.7. So this graph is suitable. It goes with the results we have received here, like this, 0.7 times A. So therefore we can decide this one is correct. This graph is correct. So the second one is correct, because roughly the velocity in B, in stream B, this one A, roughly the velocity, the magnitude of the velocity shows here 0.7 or something close to that, but it is not 0.5 here. Obviously it is 0.5 here, something between 0.5 and V. That means it may be 0.7, but these are wrong exactly, because this is 2 times V. If this one is V, then this one is this one shows 2 times V. So if this one is V, this one shows 1/2 V or something like that. That's wrong. Then increased, however increased, it can't be. So this one is constant, so that also can't happen. So according to the results we obtained, this one is the correct one. So children, I said that this ratio is equal to 0.7. So if you can't say you don't know that, because if you have learned the AC theory, that means about transformers, AC to DC, that means the DC component of AC, the VRMS value. So there is an equation we come across, V root mean squared voltage is equal to 1/√2 times V peak. So this equation you must learn in electricity, the lesson electricity. So here we come to know that this value is 0.7. When you learn this equation, you come to know that this value is equal to 0.7. So if you remember that, you can use it here without going into lot of mathematics to solve this. Without solving that, just you have to use this value that is in your mind and go to the correct answer. So let us therefore talk about what is this VRMS, so that then this video may be very useful to most of the students. Therefore I am going to now discuss about this topic. So children, you must have learned what are transformers. So this is the symbolic diagram of a transformer. So this left side coil is called primary winding or primary coil. This right side coil is called secondary winding or secondary coil. So this medium in between these coils is called soft iron core. So when we connect these terminals to the main current, main supply, we input 230 volts to this transformer. So that is we call the AC. AC means alternative current. That means it varies like this at a frequency 50 Hertz. So to denote that, we use a symbol like this. That means we should supply AC, not DC, to these terminals of the transformer. So directly from the output, that means from these secondary windings, we can take a reduced voltage such as 6 volt or something like that, since this one is 230. Something reduced or increased, normally usually we reduce for home consumers, for home consumes, we reduce the voltage. That means step down, we say step down transformer. When we reduce the voltage, we call it step down transformer. We call this transformer then step down transformer. When we increase the voltage, we call it step up transformer. It depends on the number of turns in this secondary winding and the ratio, actually ratio. If the turns, the number of turns say in 1 here, if the number of turns here say in 2, then the voltage supplied here, if we say V1 and we get voltage from here V2, then V1 divided by V2 equals N1 divided by N2. So from this equation you can calculate what is the voltage you can get from this secondary winding, if you know the number of turns and the supply voltage. So that is what you know already. And now what I am going to discuss is between these two terminals there are two types of voltage. One is called VRMS, the other is called V peak. So let us discuss what are they. So before we go into detail, if I explain what this transformer is, because nowadays children don't get chance to see such a device. So there is a frame like this, metal frame. Like this. So there is a sort of metal sheets. So they look like this. Inside that there are two holes like this. So metal sheet like this. It's a metal sheet like this. So there are number of metal sheets like this, about 50 or 75 like this. Then they are fixed like this, they are placed like this, 1 over 1, those sheets like this, 1 over 1 they place these sheets. So we get a sort of cube then. Those metal sheets are kept on 1 over 1 like this. Then we get a sort of cube like this. You see, like this, a cube. It will look like this. After keeping 1 over 1, they look like this. It's a cube. We can make using small iron sheets, we can make a cube. So in this cube they wind the coils like this. Actually, first of that they use a bobbin. You know, there are bobbins like this to wind threads or wires. So using that bobbin, so in this diagram what you can see is a transformer. So this one is that bobbin, this plastic piece is the bobbin, this one is the bobbin. So in that bobbin they wind these wires, we call them coil enameled wires, not just copper wires. We wind this about 1000 turns we wind, so that one is going to be the primary. So about 50 turns we wind again, that is going to be the secondary winding. So like this transformers are constructed. So there are two windings, two coils. So after that they fix a casing like this around this block of sheets like this, and cover it and fix it so that they don't move. There are two holes to fix to an external casing. So this is the transformer. So there are then two wires coming out from this primary winding, and also two wires coming out from this secondary winding. Sometimes they take three wires from this secondary windings like this, one connected to the center of the coil like this. There are then three wires. So this transformer is something like that, because this one is the secondary, this one is the primary. Here you see blue color wire and then yellow color wire, and again one blue color wire. There are three wires. There are small holes here, you see, in the bobbin. So from that bobbin rise up these three wires. The center one is yellow. That means this secondary is able to supply two voltages between these two wires, say 6 volt, and also between these two wires again 6 volt. If we use these wires, this one and this one, we can take 12 volts. If we use this side wire and center wire, we can take 6 volt. That is how it is made. So that is why they say 6 volt times 2. 6 volt times 2. This one is output. Output is the voltage that we get from the secondary coil. So 6 volt times 2. That means between these wires we can get 6 volt. Again between these wires we can get another 6 volt. If we like, we can use it, otherwise we can just keep it aside. So input means this one is input. Input means the primary coil. So to that we have to supply 220 volts, 50 hertz the frequency. So normally the main supply we connect to this terminal. So actually terminals means these wires, these red wires are for high voltage like this 220. This blue and yellow wires are for this 6 volt low voltage. You can guess it. The diameter is very high here, you see. So that is the transformer. So I show it because these days children don't get chance to see these things, because these types of transformers are not in use now, because they have modified new circuits for phone chargers and for laptop chargers. They use some electronic methods. They don't use these transformers, but still they ask questions in the exam. Therefore we should know what is this transformer and how it the function and all that structure and everything we should know, because in this main supply line, the grid, in the grid you must have seen there are two big poles by the side of the road, and from the electricity board I mean. So there are big transformers, you must have seen. There are big transformers like this, they have placed to supply currents to houses. So there are big transformers, you must know. By the road you can see those transformers, so they are the big version of these small transformers. The same function, same thing happen. There are two coils like that, same thing happen. So now let us go to the theory part. From a transformer like this, the voltage that you get is something like this. It changes positive to negative, negative to positive, positive to negative, again and again. That means the current flows, if we connect a bulb or something like this here, at what time the current flows this way, next moment the current flows this way. So 50 times per second that varies, that change 50 times a second, very rapidly the direction change. So therefore we call it AC. AC means alternative current. Alternative current, here you see in this topic alternative current, the first letter of both the words are taken, therefore we say AC current. So this voltage is therefore we call AC. The voltage we have taken to the y-axis and the time to the x-axis, so it changes like this. So this maximum voltage at a certain time we get is called V peak, that is denoted by this letter V and a small p at the bottom like this, Vp. So that is a certain voltage we have to use, and we have to use in equations, and sometimes we have to calculate, and that is one voltage out of this two voltage that we are going to discuss. So the other one is called VRMS. What is that? So normally in simple words we can say that is the average voltage, but that word is wrong. Just I use it so that you can easily understand. Just imagine that it is the average voltage. This VRM is average voltage, but you are not going to write it in the exam. Until you understand, only we use that word. So average voltage means, so this voltage changes, so there must be a average. Average means a constant voltage which is not changing. So if this voltage going to the positive side and negative side rapidly, repeatedly, so the average must be 0, because there are positive parts and negative parts, all together they cancel, and the average must be 0. But in practical the average voltage is not 0, because if the average voltage is 0, we can't use this voltage. Why? The average voltage is 0. Then if we fix the bulb, then bulb doesn't light up, because it gets no voltage, because the average voltage is 0. But for sure we know the bulb gets light up, and there is a voltage. There is a voltage even though the direction change. Even though the direction change, we know that there is a voltage. So therefore we have to somehow find out a average voltage for this changing AC voltage. So there is a method for that. After following that method, we can find out the average voltage. So that is like this. So now let us try to understand what is VRMS, what VRMS is. So first of all, let us see the definition. So there are definitions, and little by little they change, but the structure is same. The words sometimes they use are different, but the idea is same. The first one, the root mean square value of an alternating current is defined as that the value of steady, that means DC voltage, which should dissipate heat at the same rate in a given resistance. So the next one is RMS voltage, root mean squared voltage, or root mean square voltage of an AC waveform is the amount of AC power that produces the same heating effect as DC power. So children, now I am going to explain this to you, because you can't understand, I think, what are these words. There is a wording like this, but I think you are not able to understand this. So therefore I am going to explain what is this. So children, let us imagine that you have this transformer, and it has a peak value, say 8.52, that means the maximum voltage. This one is the peak value, V peak. It is equal to 8.52 volt or something like that. Then what you do is, you light up a bulb using this transformer, that is AC. So even though it is AC, you can easily light up the bulb. It doesn't matter, because the bulb doesn't feel the current, whether the current is this way or that way. Just bulb light up. So you can see a certain amount of brightness of this bulb, certain amount of power or brightness of this lighting bulb. So you can watch it by your own eyes. So using a meter which is called lux meter, you can use your cell phone. You can download an app. There is an app called lux meter. So if you have installed that lux meter app in your mobile phone, you can measure this intensity, the brightness of light, using that lux meter installed phone. You have to place the phone from the bulb a certain fixed distance, without moving the phone. The phone should be steadily fixed at a place, and also bulb should be steady without moving, so that you can measure a constant value. So the phone will give you a constant value for intensity. Intensity means brightness. So you measure that. So then you keep that value aside, and then you light up the same bulb using a DC power supply. So DC power supply we should be able to change the voltage of that DC power supply, say from 3 volt to 10 volt. We can change that variable power supply. So this arrow indicates that. So you remember, or you can take down that value given from this lux meter, say 2400 units, the intensity. So so you get the same intensity. You have to place the you have to make sure that you didn't change this distance or the angle. Therefore you don't touch this after fixing the bulb, or either the bulb or the phone which is installed with the lux meter. And then what you do, you increase the voltage until you get the same intensity, say 2400. Then the intensities are equal. That you can do by using your own eyes. Even roughly you can get a value. Then you measure this voltage using a voltmeter. So that may be something like 6 volt. If the peak value of this transformer is 8.52, you will get something like this. So this voltage, that means so this intensity means the power. The intensity means power. So this one, the power. So AC power here, this one is AC power, because we used the transformer as the AC source. So AC power that produce the same heating effect as DC power. That means the power dissipate when you use this DC power supply must be equal. So the same power. So if the power is P here, so the same power must be dissipated from this second setup. So that is why I said you have to measure the intensity. Intensity is proportional to the power. So if you measure the intensity, so you can assure that power is equal in both cases. If power equals in both cases, here we used AC voltage, this one. Here we used DC voltage, this one. So we say this voltage is Vrms of this peak voltage, this AC voltage, or this AC voltage, RMS value of this AC voltage. So that is how practically we measure it, we find it. So in this graph, it is a little bit smaller value. You see, this one is 8.52, this one is about 6 volt. So that is steady voltage. This one is the steady voltage because this battery supplies a steady voltage. It doesn't change up and down, positive and negative, as this transformer. Transformer usually gives voltage always changing positive to negative like this. But this DC voltage is steady, so that is why they say in this one, I think, steady DC voltage which should dissipate heat at the same rate. Same rate means same power. Power must be equal, not the voltage. Voltage is not equal, but the power must be equal, either in this AC case or in this DC case. So the power must be equal, so that the power is equal, so you can measure a DC voltage. So that is called Vrms. So that lies here in this graph, that lies here, little bit below than this V peak value. So this one is Vrms, this one is Vrms. So to find out, to calculate, so I explained how you find out it by using these instruments practically. So if you wish to find out it by using just equations, you can use this equation. You can use this equation. You are not supposed to derive this equation, it is not in your syllabus, just you have to keep in your mind Vrms equals 1 over root 2 times V peak. So here, what is the value of this 1 over root 2? So there is 0.7071 exactly, but you can use just 0.7. So like this. So you have to keep in your mind memory this value. You know, normally root 2 is 1.42, and as same as that, you have to keep this value also in your mind because it is useful. That is what we used here in this problem, question number 9 in 2021 paper. So here in this problem we used that knowledge to solve this problem. So that is why I said, if you know Vrms, you can easily recall this value to substitute here and get the answer at once. So this thing, now you know what is Vrms and what is V peak. This one is V peak, we call V peak, because if you think about a mountain, we call this point peak, don't we? So therefore this wave shape also like that, therefore we call this point, the voltage, V peak. So V peak and Vrms are there, so the relationship is this one. So you have to keep that in your mind, especially when you calculate problems using these transformers, where you rectify in electronics, you know, you have to rectify and calculate those problems, half wave rectifier and full wave rectifier, you know. So before that there is a transformer always. So first of all you have to transfer the AC voltage to DC voltage like this using this one, and then thereafter you have to apply, there are another formulas to use with the diodes, then finally you get the rectified voltage. So like that, this is very useful, so therefore keep that in your mind and learn it. So children, now I think I have discussed all things what I was thinking about, and I think you understood VRMS and VPeak. Don't say VRMS is the mean value, because mean value is 0. Here you see mean value is 0. Since positive and negative parts are equal, mean value is this one, 0. It is not a mean value, it is RMS. You must say VRMS. If they asked what is VRMS, you have to write these definitions, or whatever you might have been given, not might, surely you are given the definition, that your teachers must have given you the definition, that must be in your notebook. So keep it that your mind, you have to memorize it, keep it that in your mind, because sometimes they ask it, what is meant by VRMS. So then you have to write it like this according to the definition. You just can't use just simple words, therefore you must keep this in your mind. The words must be this, like this, otherwise you won't get marks. You can't just say that is the mean voltage or steady voltage, because you must say power. You must say the word power. Dissipate heat at the same rate. Heat at same rate means power. Or either you have to use the word power or heat rate. Heat rate. Rate means power. Here they have said heating effect as power. They have used the word power. So you must use the word power. Otherwise, just if you use the voltage, you can't get marks, because that's based on power. So children, I think now I'm going to wind up. This is enough for today. So I solved the original problem like this, and I think you can understand it step by step in a very simple manner. I reach the answer so that you can understand it, because I know you have mathematical problems. That is why I showed step by step how to simplify all these things like this. But if you are a maths in the maths stream, if you are a maths student, you don't have to be taught like this. You can easily simplify. Especially I did these things for bio students, because they face problems in simplifying equations. So therefore I especially do these videos for biology students, because they face problems in solving. They can start the equation, but they can't reach the final goal, because somewhere they make mistakes and they get the wrong answer. So therefore I showed you how to simplify the equation, and also I showed you something else in current electricity, what is VRMS and VPeak value, and also I explained what is transformer and how to get the voltage, how to find out the voltage, output voltage using these number of turns, and the structure I explained, and how it works I didn't explain. So you have to go to the lesson magnetism induction, so it is out of this scope. So whenever I met a MCQ problem in that region, I'll do that. So today we are going to wind up. So thank you very much children for watching my videos. Share this video, so my channel link with your friends, so that it will be helpful for poor children who can't understand these things. So I use the word poor to mean that the students who can't understand these things, so they can then easily catch up the lesson. So children, watch again and again my videos. So if you are happy, I think you must be happy, because I explained everything short and neat, you see. So you can keep this note. Even if you don't have the note, you might have missed the lesson from your class, tuition, or from school. So if you are happy, please subscribe my channel and make me happy too. So see you tomorrow. Goodbye.